Hello, everyone. A very good evening to all. And dear authors and invited guests, welcome to the technical session 2A. My name is Anisha Mishra, and I am the moderator of today's session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2023 through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. There is also a request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Priya Pise. Dr. Priya Pise is currently working as professor and head of the Department of Artificial Intelligence and Data Science at Indira College of Engineering and Management, Pune. Her research areas are big data analytics, cybersecurity, cloud computing, and data science. Her PhD is in the topic sensitive data sharing on heterogeneous platform for privacy preserving. She has total experience of 18 years, including industry and academia. She has published 25 research papers in various scopus, HCI, UGC, care journals, and conferences. She is an author of 4 books with 1 international and 3 national patents. She also won Best Technical Paper Award to national and international conferences. Welcome to the session, ma'am.
Thank you, ma'am.
Okay, so now we will start with the papers, and I would like to invite our first presenter, Lakshita Sehgal, to present her paper on the title Comparative Study for Detecting Cardiovascular Disease Risk Using Machine Learning and Hybrid Models. Dear presenter, you may please start your presentation. Okay, so Lakshita has just joined the meeting.
Hello.
Yeah, Lakshita, you can present your paper now.
Okay, sure. Is my screen visible?
Yes, it's visible.
Okay. I'll go on with the presentation. So hello panel members. Today I'm here to present my research paper whose paper ID is 114 according to the SmartCon Easy Chair ID. So the title of my research paper is Comparative Study for Detecting Cardiovascular Disease Risk Using Machine Learning and Hybrid Models. Here in this paper, we have 4 authors. I myself and my 3 other co-authors are Sarthak Sood, Sayyam Sood, and Anshul Agarwal. So let me just go through how the presentation will flow. It is just a presentation flow chart. Like first of all, I'll introduce the topic and what I thought to do and why I did this. Then then what is my proposed model, different models used and classification metrics and everything. And then we'll move to conclusion part. Am I audible, right? Hello?
Yes, you're audible.
Yeah,
Please go ahead.
perfectly.
Okay, fine. This I'm not. Okay. So initially, I want to introduce the topic like cardiovascular disease is disease related to heart, like sometimes oily fats and other things. The vessels in our heart becomes heavy, and heart problems arises. So and many cases we have seen that it's very late then we recognize that yes, a person is suffering from heart disease, and the recognition thing is very costly also. Like we have to go through a lot of things, and but if we go through a simple blood test which cost around 1,000 rupees, so with that blood test only we can tell about the condition of a heart. So here I have taken a data set which was freely available data set from the Kaggle itself, and applied approximately more than 30 models, some basic model like SVM, KNN, SVD, LGBM models, and then made a hybrid. Collected them. Some are hard code and some are soft coded. So in that way, I got 30 models to find out what runs the best to get the best accuracy till now. This was the idea which we all wanted to execute, to find the best model till now with a great accuracy, because in this thing accuracy matters a lot in health issues. So how the model goes on is like, first of all we get the data set, then the data set is pre-processed according to our requirements. Then the pre-processed data is passed into various ML models. I have passed into models and hybrid models, and after that classification happened, and everything happened, and after that we got accuracies. After getting the accuracies, we all just compared which model is the best model for our dataset right now according to the results. And along with that, we had just done some hyper tuning, hyperparameter tuning, and everything else, so that we can get the best results. So let me come to the models used. Initially, first of all, I have used naive Bayes. Naive Bayes is assumed that the presence of one feature in class has no influence on the presence of any other features. It is basically a probability model which uses, this is the internal working of Bayes I'm talking about. Then random forest. Random forest is just like it takes a lot of decision trees and ensemble them together and get the results. Then KNN, k nearest neighbors, it just groups, it makes the decision based on similarity, and based on clusters. Then we have support vector machine. It divides it into hyperparameter planes and then classifies. Here we are, everything is supervised learning because we have data set and we have the answer, and just we are training it so that if we try it on the test data set, then we get good results. Then XGBoost also. XGBoost is a high-end level of ensemble machine learning model, XGBoost, which is very in nowadays. Then we also made our own artificial neural network model through this ANN. Then LGBM and hybrid. Now let me come to the hybrid models. Now for hybrid model, what we did, like I took KNN and LGBM. Both the models, just combined it together, hard coded it, ensembled it together to get better results. After ensembling 2 to 3 models, what we found out that the ensemble models gave better results as compared to the single model. Better judgment, better results. So we ensembled many models like KNN plus LGBM, KNN plus random forest, XGBoost plus LGBM, KNN plus XGBoost, then ANN plus LGBM. Like this, we have gone, like here I have mentioned too, we can go for 2 to 3 models also as it is. Now here what I have we have done, hard code. There are two types of thing: hard code ensemble and soft code. Now let me explain you the difference. In hardcore, what we do, if I take KNN and LGBM, it's like the 50% probability of the result would be taken from KNN and 50% from LGBM. But in soft, I can do like, I want to give preference to KNN more. So I set like 70% KNN, the results coming from KNN, and 30% the results coming from LGBM. And when the combination of ensembling is there, the probability is set like that. So we can do both the ways. Here, uh, preferred because of the results and everything, we have preferred the hard coded one. We can go with anyone. Then for the classification metrics, now it is a classification model. So we have to tell that if we are going through some disease or not. So first of all, we have precision. Precision is just predicts true positive and upon true positive plus false positive. These are just some metrics. We generally use precision recall. F1 score is the harmonic mean of precision and recall and accuracy for that. This is our classification metrics so far used. Then, yes, the most important part, the results. Now let us compare the result. This is the graphical representation of results that we got. These are all the models used, and this is the accuracy goal is a comparative analysis so that we can see that which one is the best one. Until now we got ANN plus LGBM as the best with the accuracy of approximately 89.4%, 89.4, 89.5% till now, which is a very good accuracy as compared to the previous ones. Then it's just in conclusion that for prevention of many deaths and improvement of patient health, and both made possible by early detection of cardiovascular disease. So machine learning and deep learning models provide a very cost effective way and easy way for the technicians to find out. Even if they don't know what's going inside the models, they just can put the information. We can create a UI for them that just create, say, set the data set, and the model will run at the behind, and just they can find out if a person is going through that disease or not. So the best accuracy received till now on my the dataset used by me is 89.46 on the basis of ANN plus LGBM model. So this is basically whole idea of my research, which I presented in this paper. Thank you.
Lakshita,
Yeah.
good evening.
Good evening, ma'am.
Can you please go to your PPT number 1?
Yeah.
The first presentation. First PPT of course. Okay, first of all, I really appreciate the topic that you have chosen as in comparative study of cardiovascular disease risk using the recent techniques, and
Hmm.
in that the one I have heard and seen that
Hmm.
you are totally focused into the hybrid kind of the model.
Hmm.
So I need to give you a compliment for doing the extensive literature review for comparative analysis first of all. So
Thank
I'm
you.
really happy to see the clear comparative study for a particular disease. So my question to you,
Hmm.
mm, is on the data set, where I did not find that you have commented anywhere in your presentation about the kind of a data set that you have used, maybe, a sample size from where you have used it, or, have you tried for actual data set, or of course the Kaggle. I heard in between that, you worked with a Kaggle data set also for one of the module, but
Hmm.
can you please comment on it? Like, what can be the sample size? Because see, if you're going to consider the comparative study for the heart diseases, you know that the extensive data is available. So how
Hmm.
much you have taken, from where you have extracted that? And next question, next continuous question to it, I guess you can answer both the questions if you and your buddies, four buddies are here. Sorry, three
Hmm.
buddies are here.
Hmm.
So, how much time it took for you guys to pre-process the data? I'm, curiously interested in it.
So let me come to the data part. Firstly, I want to answer that. So the data set here consists of approximately 70,000. It was taken of 70,000 patients, and 12 things were included: age, gender, height, BPs, weight, glucose level, cholesterol levels, even if they smoke or if they consume alcohol, or how much physical activity they have, and whether they have cardio disease or not. So these were the parameters on which we judged. And now that there were 12 parameters for pre-processing part, like for BP we have two BP, low and high. So for that part, we just what did during pre-processing, we found BMI index through that, which was not initially present, but through the dataset we found BMI index. Then new things like map, mean arterial pressure, and these formulas were applied through the data set. So that way a better results can be found out from that. Like we found new columns through the old pre-existing data set. So this was all pre-processing part. So for if you're asking about the time, I am from the BTech background. I don't have much knowledge about healthcare and everything. I just wanted to explore. So it took quite a time first to read that what happens, what is behind the scene. It's just not a one day thing like I sit and let's do the code and everything. It was a very intensive study, like what is the effect, like if I add BMI, should I add BMI, if I am adding BMI, what is the results coming, and now if I have subtracted the BMI part or map part, then what are the issues coming or what are the things. So this I took like this whole project and comparative study took almost 3 to 4 months to complete with code part, because we have to firstly pre-process it, check that things are going well, then apply 30 models. For applying 30 models, you first have to code the 30 models, then we have to run it on, and running also takes a lot of time. And firstly train, then test, then hyperparameter tuning comes, that things comes. Then we have to check that okay, the like if it is a thing in that if one simple model is giving less accuracy, so the combined model or hybrid model would to give less accuracy because of the training issues. So for that selection, that yes, if one is giving less, then we have to eliminate that for the hybrid thing. So these all things approximately took us 3 to 4 months. This is
Okay.
the answer I would like to say, if it's satisfactory.
After listening to your answer and after mapping that you are a BTech student, I must appreciate, the work you guys have done. If I am not wrong, it's a final year project, right?
Yeah, kind of.
Okay, very
Like
good. Very good.
I'm very much enthusiastic and interested in research work. So
Mhm.
I just like taking challenges and
Exactly.
explore.
So you are proving your name here, Lakshita. Okay.
Yeah. Anything else, ma'am?
That's it. That's it. And your explanation was, up to the mark. Like I don't need to ask you any more question. You're satisfying and sufficing the need of your title, in my opinion.
Okay. Thanks a lot. Can I
Okay,
leave
thank
now?
you for the great presentation.
Thank you.
And now, moving further, I would like to invite our next presenter, Pooja Srinivasan, to present her paper on the title Anomaly Detection in Medical IoT Devices Using Federated Learning. Um, Dear presenter, you may please start your presentation now.
Yeah. Just 1 second. Let me just share my screen.
It's a kind request to all the participants to please put on their cameras also. It's mandatory by the norms conference, in my opinion. Nisha?
Yeah. Is my screen visible?
Yeah, it is.
Very good afternoon to the honorable panel. Myself, Pooja Srinivasan, and my teammates, Anushri Manoj K, Neha, and Arpana M. Ramaswamy, guided by Dr. Namrata M, are here to present our research work, Anomaly Detection in Medical IoT Devices using Federated Learning. This is a brief outline of our today's presentation. So coming to a brief introduction on what our project deals is with, we have integrated IoT and anomaly detection and federated learning. IoT devices are just pieces of hardware like sensors such as heart rate detectors or LM35 temperature devices, etc. And we have already seen that IoT devices as such has a great impact. So we want to extend this to healthcare and see the medical applications to this. And especially in healthcare, getting data and timely detection of data is very important. And anomalous detection could lead to patients' health at risk, and can have drastic effects also. And to do this, we're using federated learning to detect anomaly in data. So now coming to the problem statement. The problem statement is anomaly detection in medical IoT devices using federated learning. This has a prime application in the healthcare sector, as a patient's physiological parameters like heart rate, temperature, they need to be constantly monitored. And any anomaly in these readings, that is from the sensors, may lead to erroneous diagnosis and treatment. So that's why timely detections of anomaly is important. And anomaly detection refers to the problem of finding patterns in data and do not conform to the expected behavior. That's how we define an anomaly as such. And in our study, we use federated learning to detect anomalies in medical IoT devices like the heart rate and temperature sensors. And the data from the sensors of different patients is collected and trained locally on edge devices. And the results of these local trainings are aggregated to the central federated learning model, which detects the anomaly in the data. This method of local training, where only the training results are shared and aggregated, and this actually preserves data privacy. If you see in healthcare, there are many things like HIPAA rules to be followed, where we can't have patients' data being exposed. So this is one of the advantages of federated learning. Now, coming to our research as such, so we know that human body temperature and heart rate are important for diagnosis and for treatment. And we can use sensors like the LM35 and heart rate sensors to get these vitals. In this study presented by Sai Mansa, we understand how vitals can be monitored using different sensors using Arduino. The study enables us to monitor physiological variables, including the MAP and body temperature, to ensure that the right countermeasures are taken. Any irregularity in the data must be promptly detected. This detection should preferably have a low false negative alarm despite the low SNR condition. So in Arjit Yukil and team study, we see that they have done cardiac anomaly detection system and deployed it on a smartphone. And this is really important when it comes to the vitals and how the vitals are measured, and further course of treatment is basically determined by this. We have all seen that machine learning has a very great impact, especially in anomaly detection. Like the model picks up the new skills from the data and trains and conceptually even adapts. It is able to even do for a very huge data set, which is not manually possible. And anomaly detection has been implemented in both supervised and unsupervised machine learning algorithm. In the research proposed by Girik Pachori and team, we see that algorithms like decision tree, random forest, KNN, linear regression, and additive regression are some of the algorithms that they have used to find anomaly detection in wireless sensor networks. Moving further on, we see that there are various works in which machine learning was used to detect device failures and anomaly detection. One is an unsupervised algorithm, and the next work presents a comparison of different models to detect anomaly in IoT environments. However, a virtual IoT environment was used to generate synthetic data, and machine learning models were trained on this data. But in a real-time system, it can lead to compromising privacy of users, where the model has to be trained on confidential data of different users. This is where like federated learning actually comes into the picture. So simply put, federated learning is nothing but decentralized form of machine learning. As shown in the figure, the centralized machine learning application, which will have a local copy on all devices, the model will gradually from the information gathered from the device, and then the training results from all devices are aggregated in the centralized server, and the central model is updated from the aggregated results, creating a smarter version of the model. So each time it gets updated, the model also improves. In this case, even privacy of the user is preserved, because we are not taking the actual data from individual models, but we are taking the result and doing it. So basically, the central model aggregates the result. So that way we are ensuring even data privacy also. Now, getting familiarized with federated learning architecture, we know that we can say easily that from different research that federated learning has a lot of impact, especially in IoT data sharing or attack detection, mobile crowd sensing, and IoT privacy and security. And FL has applications in, of course, in healthcare, then smart transportation and unmanned aerial vehicles, smart cities, and even smart industries. It has unique advantages like data privacy enhancement, low latency network communication, enhanced learning quality, to name a few. One of the FL like examples that we can give is like here as shown in this picture, cameras, like the vehicular cameras traffic is captured, like the license plate information is captured, or radars can capture GPS of vehicle or in bus stop. There's a possibility of even capturing the exact location of any vehicles like there and stuff, and that, and not exposing the private information as such. So let us look at some papers that have the application of federated learning in anomaly detection. So Rieto and team have put forward an approach for an on-device anomaly detection by FL. They proposed a model where training is done on edge devices. The paper shows a simple but important application of federated learning for anomaly detection. Zhang and team proposed a framework for FL where again it was on-device anomaly detection, but the model detects intrusion attacks on the network. The paper compares the different training models, like training on local data set, then on combined data set, and training via federated learning. The team used different metrics like accuracy, true negative rate, true positive rate to compare these models. And then Ilu and team proposed two papers, where in the first paper, the DAD model and CNN LSTM model, along with federated learning, was used to detect anomalies for industrial Internet of Things. In the second one, they addressed the importance of timely detection of anomalies caused due to edge device failures. The framework proposed will enable the model to be trained on decentralized edge devices, that is AM, CNN, and LSTM. So when you say federated learning, like why have we chosen federated learning might be the main question here. Anyone can say easily that you could have done it with machine learning, right? Anomaly detection for healthcare devices. The main reason why federated learning is preferred over machine learning is the use case, as machine learning would require all sensitive medical data to be accumulated and training to be done on an aggregated data. Whereas in FL, the model learns locally on individual devices, and only training results are accurate, like aggregated, and not the actual data. This preserves the main thing in healthcare, that is data privacy. Now, coming to the total high level design of how this project was like approached, like if we see that the research we started with the identifying the vitals, like especially when it came to anomaly detection, there can be a range of things for the human body, but we narrowed it down to vitals such as heart rate and body temperature, and procured the necessary IoT devices. Future, when we plan to implement it, we have like a idea in mind for that also. And once like the circuit and all is ready for getting the data, the data generated can be cleaned and processed and stored in a cloud database like Firebase or MongoDB. And then this model can be trained locally. And then the final aggregations results can be done by the federated learning model. And finally, the anomaly detection is done. So the following slides here have the total, our complete research references, what all we have referred to. And this brings us to the end of the presentation. Any questions?
It's a kind request to all the participants also. You too can, ask any question if you really have. I really would like, participant also to talk, because the conference is a common gathering where we all can exchange our thought. Is it not? Participants, anything from your side? All good. Pusha, can you go to your slide number 1?
Sure. Yes.
Anomaly detection in a medical IoT, using
Yeah,
federated
medical
learning. Yeah. I have got a couple of questions for you, Pooja. First of all, your presentation was very precise. It was up to the mark to what you wanted to tell about your topic. So I must appreciate you for that. And a thought came onto my mind. Why? What is the motivation behind anomaly detection in a medical? Because
the main
if
motivation, if I have to say, like, especially when it comes to the healthcare sector, it's really important you have the correct diagnosis and timely diagnosis. For correct diagnosis, you need to have the correct data also. Let's say, okay, there you get medical help at the correct time, but it's not the correct diagnosis. Like, instead of being prescribed a paracetamol, you're prescribed an antibiotic. It has opposite effects, right? So that's one of the main key reasons why data, especially in healthcare, is really important.
Okay, no motivation. I mean to say, did you find any anomaly detection ever? Have you tried for any case study for it? Because recently we all have heard that data of EMS has been
Yes,
fraudulated.
ma'am. So regarding that, so if you remember during the COVID time, especially during lockdowns and all, there were these videos that were forwarded, the WhatsApp videos where we had pulse rate sensors, even without a human pulse being given, like even without for the spirometer and all, without human beings actually using it. For a pen also, it would show that there's a pulse. But how can a pen have a pulse? So that's how we came up with this idea of, actual correct data, and detection of anomaly in data is really important.
Okay.
Especially in IoT devices.
Mm-hmm. Okay, and I see there is a strong literature survey, in this
Yes.
area that you have done, and a clear distinction between what is ML and what is
Yeah.
the FL is, right?
Yes.
So, did you go ahead for the implementation of, any use case over here?
We have partially done it. So what we did was we took a breadboard and simple sensors, and we started generating the data. If you see the regular Arduino device and those sensors, they don't give accurate values because those sensors get heated up really fast, and they are not industrial grade sensors. So they give anomalous data. So that's how we were able to identify our thing if it was working. The theory that we proposed and actual implementation, does it match?
Okay, okay. Because you've shown me on one of your slide. Can you go to that? Maybe your proposed diagram.
Yeah,
Yeah, where you did, high level design. I could see that you actually did some circuitry
Yes.
part and some connection, right?
Yes.
So did you go ahead with a registering patent for it for
We
what
do have
prototype?
plans. We have plans for it in the future.
Okay, okay, okay. That was my suggestion to you. You surely can go ahead, because I
We
believe.
are in the process of it. We are just we are stuck in the paperwork.
Okay, okay. Okay, that's it from my side, and all the very best to you.
Thank you so much, ma'am.
Okay, thank you so much for the great presentation. And now, moving further, I would like to invite our next presenter, Vaishnavi Vinay. to present her paper on the title Evolution, Trends, and Future Developments of Business Intelligence. Dear presenter, you may please start your presentation. Okay, so Vaishnavi is not present in the meeting. So for now, we'll move further to our next presenter. And I would like to invite Karan R. Jain to present his paper on the title Knowledge Discovery and Visualization of UMLS based on Complex Network Analysis. Dear presenter, you can start your presentation now. I think he's not able to connect with us. Okay, we'll announce his name in the end of the session again. And for now, we are moving forward to our next presenter. And I would like to invite Govind Suryavanshi to present his paper on the title Multi-Class Discriminator for Blind Stagnalysis Using Statistical Features of Digital Images. Dear presenter, you can start your presentation.
Good evening, ma'am. My screen is visible?
Yes, it is.
Okay. So my paper title is it's a multi-class discriminator for blind analysis using the statistical. Just wait, I will start my using statistical features of digital images. Myself, Govind R. Suryavanshi, and co-authors are the Dr. Suresh Mali and Pramod D. Patil. So these are the outlines of my presentation. Basically, the social network services are broadly divided into the different categories. Like we are having the social media is there, then internet users are there, and gradually the number of internet users are increasing in last decade. So if you look at in this graph, the increase in the SNS users are going to be represented. So in 2013, there are near about 97 crores users over there. And right now, the total number of users are crossing 300 crores. So the real world risk, security risk. So this chart, it represents the security risk. Now there are 54% of risk is from the pornographic and erotic materials, and from social media it is going to be 16%, and for the illegal software, so it is going to be 14%. Now if you look at it, so 16% of the this security risk is from the social network. Now there are different threats are there for the SNS users, like the multimedia threats is there, then we are having the phishing is there, spamming is there, also the covert communication using steganography is there. So there are certain solutions are also for that threat. So like we can have the watermarking, the malware detection is there, phishing detection is there, and stag analysis is there. So this my work is focused on this stag analysis. Okay. I will put my sorry. So basically, stag analysis is a technique to find the miscellaneous information within the multimedia data. So that this can be done using the stagnatic softwares, and that can be use the supervised learning or the unsupervised learning. And obviously, we have to extract the features from the multimedia. So that features are the higher order the features. And now the motivation for my work is that the many interested techniques have been created, and its continuous evaluation is guaranteed by the growing need for the information security. All are potentially open to abuse and can be used by the criminals and terrorists for the covert communication and planning for the terrorist activities. And the steganography may be with the safest form of the covert communication. So these are the motivation for my work. Now, there are certain challenges during my research work. So the first one is that to discriminate between the cover and stego media. The second one is that identification of the technique that can be used for the cover communication. That is identification of the steganography methods. The third one is that estimation of the length of the hidden message. The fourth one is that the identification of the stego bearing pixels. Exactly which area has the hidden information. And the last one is that the retrieval of the stego key. Now, just I have gone through near about 126 papers, and just I have discriminated that, or I have classified that papers in different categories. So the specific analysis, then visual analysis, the statistical analysis, then we are having the spectral analysis there, and the transform domain analysis are there, and the universal analysis there. So basically, my work is on the universal analysis. Universal analysis is what exactly, or the blind analysis is what. We are not aware about what kind of the technique is used to hide the information in the multimedia. So instead of that embedding technology, we are going to try to extract the data from that the cover media. So it may be the embedded in the spatial domain, it may be embedded in the transform domain, or it may be embedded in the different domains. So that is the universal analysis techniques. So from the literature review, I have used different parameters, and this is the graph which represent the bifurcation of the papers. So first one is the spatial domain. So there are 19 papers I have used for in spatial domain. Then for the transform domain, the 17 papers. For the IQM, that is IQM, it stands for the image quality matrix. Then there are 27 papers are there. The target text analysis is 35, and the universal analysis is 15 papers are there. And out of that literature survey, just I have gone through all the papers, and I have come across that most of the researchers have used the BOSS-based database set, and obviously I'm going to use with the same data set, that is the BOSS-based. So there are 22 papers out there. Just I have got the 22 papers that researchers have used this BOSS-based database. Just I'm going to use the same one, that is BOSS-based. So this is the functional block diagram of my proposed technique. So first we are having the image databases there, then we're going to select the image, then feature extraction is there. So this PIQM is the PIQM stands for the prominent IQM detections. Then we are having the IQM selection is there, and the GRUS, that is the proposed technology, that is the golden ratio universal analysis. So basically the items are divided into 4 different, that is 6 different categories. The correlation measures are there, age-based measures are there, the spectral distance measures are there, then context measures are there, human visual system measures are there, and also the pixel different measures are there. So this is the diagram. It is going to represent the bifurcation of the IQM in a different classes. So the relationship between the IQMs, the first one, the smaller the pixel difference implies the higher correlation between the uncompressed and compressed images. The spectral magnitude measures are correlated with the pixel differences or the correlation-based measures. The next one, for the third one, the multi-resolution distance measures is ordered with the HVS based measures, and HVS measures are highly correlated with the context probability measures because they use the interband correlation along with the textual information. And in pixel difference and the age-based measures they are very close to each other, and spectral measures are highly sensitive to the coding artifacts. Now I'm going to use 3 different performance measures. The first one is accuracy, then the error rate, and the detection rate. So now this is the information about the data set that I have used. The BOSS stand for the big hour steganographic system. The BOSS is a competition for the breaking or analyzing the steganographic techniques. So it has near about 10,000 images of a size 512 by 512 of a PGM or the JPEG or the BMP format. So that's I use that images. So this I have worked on the color image as well as the grayscale image. Now these are the resolution for the images, size, and the quantities. Now I have carried out 2 experiments. The first one, just I have tried to find out the impact of the DC domain steganography on the IQMs that are sensitive to spatial domain. And then I have another experiment. I have find out the impact of the spatial domain on the DCT domain. So the first one is that first experiment. So to find the effect of the DCT domain steganography on the IQMs that are sensitive to spatial domain. So in that for this experiment, I have used the BOSS-based data set, and in the frequency domain, just I have selected the FI algorithm. It's for the spatial one. I have used the fixed stego. And for the wavelet domain, so I'm going to use the J unword algorithms. Now this is the input image. This I have extracted features from this image. Okay, and then I have used some standard the parameters to calculate or to look at the impact of that embedding techniques. So here the blue one, it is going to represent the standard deviation of the cover image. Now the F5, so it's the right, that is the next one is F5. Then we are having the light green. It is going to be the picked stego, and for the violet demo, so it is for violet the J inward. So it is somewhat is less as compared to the cover one. Now, if you look at this one, so there is no significant changes in spatial domain, right? So if the cover image, the blue is the cover image, and the light green, it is going to be the this standard deviation for the spatial domain embedding. So there is no significant changes in the spatial domain. So it means that we cannot use the standard deviation for the bifurcation or for discrimination of the cover and the spatial domain embedding. So that is the output of this, or that is the, you can say, conclusion of this slide. Similarly, for the kurtosis, now that there is no significant changes in spatial domain. Now the skewness, so there is no significant change in the spatial domain also, okay. And for pixel density, there is no significant change in spatial and the frequency domain. So these are the conclusion from the first experiment. Now in second experiment, just I have tried to find out the impact of the spatial domain steganography on the IQMs that are sensitive to the DCT domain. So same data set I have used and same algorithms I have used for that one. So I have extracted the feature from the same images. Then we are having the cover image, the stego image after embedding the data in that the stego image. Now this is the results of that experiment. So the changes in spatial domain caused by the DCT embedding and the number of pixel difference in the spatial domain. Now this is the histogram chart. It represents the pixel difference in the spatial domain. Now, the number of change in DCT coefficient versus the probability of the changes with respect to the DCT values. Now, here we are having the probability of the change, and then the number of the change DCT coefficient versus the DCT values. Now, observation of this experiment is that the zero DCT coefficients have less probability of changes, and high DCT values coefficient has a maximum probability of the changes. So, for the pixel measures IQMs, the standard deviation of the frequency domain is increased, but for the wavelength domain, it is decreased. There is no significant changes in spatial domain. So for the correlation IQMs, so there are significant changes in a frequency and the wavelength domain, but they are not more effective in a spatial domain. So from this two experiment, it is come to the conclusion of this two experiment is that we need more features which will be significant for the discrimination as the stego image or the cover image, or we need another approach to calculate the features. So we have proposed a new technique, that is a golden ratio universal stack analysis from the previous work from the literature. So we have observed that most of the researchers have divided the images in a block like the 16 by 16 or the 64 by 64 blocks, or somehow some researchers have used the whole image for the processing purpose. But what we have proposed here, so we are going to use the golden ratio for the feature extraction. Now the two quantities are said to be in a golden ratio if the whole is to the large as the large is to the smaller. Okay, now the whole is to the large as the large is to the smaller. So we can also observe the golden ratio in nature also. So we are having the sunflower, the growth of the cyclone. So these are the best example of the golden ratio in nature. Now, so how we are going to calculate that one? So this is the image. So just we're going to divide that image into a blocks, but that block will be divided according to the golden ratio. So here we're having the A and the B. So first we are going to have the A. So it's A and A, then it's a B. So in next iterations, we are having the A plus B. That is going to be our reference point. And then we're going to add that previous one. So that is the golden ratio. And so the B by A is equals to A by A plus B. So this is called as the golden ratio. And in mathematics, so it is denoted as a phi, and this is the constant, and the value of this phi, it is the 1.618033988749. So this is the constant one. So just we have used this technique, this golden ratio, to dividing the image, and then we are going to calculate the feature. So we have seen a significant changes in the same features that we have seen in the previous two experiments. That is the standard deviation, but here we are calculating the standard deviation using the golden ratio, the mean, the skewness, and the kurtosis. So we have calculated the same features using the golden ratio concept. Now this is the image. So image is divided into the parts with respect to the golden ratio. Okay, and then we are going to calculate the feature. So we have extracted features. So also we have used the SPAM, that is a subtractive pixel adjacency matrix. It is proposed by the Jessica Fedrich. So basically in that one, we are going to find out the pixel difference between the neighboring pixels, and we are going to create that vector of that one, and accordingly we are going to use that vector for the discrimination purpose. Now this is the algorithm for the GRUS. So we are going to have that cover image, and then we are going to divide that image into the block, and then we are going to extract the feature from that block. Now this is the algorithm. Okay, then we are going to extract the features. Now, after extracting the features, this we have seen the significant changes. So this is standard deviation without the golden ratio, and this is standard deviation with the golden ratio. So there is a significant changes. Now, if you look at here, so the first one, the cover image, and then we're having the light green. So it is spatial one, spatial domain embedding. So this is the standard deviation without the golden ratio. But if you're going to use the golden ratio, so there is a significant change. So there is an increase in the spatial domain, standard deviation of a spatial domain. So it means that we can use the same features for the using the golden ratio for the discrimination purpose. Okay, so similarly, there is a changes in kurtosis, also in the pixel density, okay, and also in the skewness. So the observation of the experiment, so there are significant changes in the standard deviation versus the golden standard deviation, the kurtosis with the golden kurtosis, skewness with the golden skewness. So now these features can be used for the discrimination purpose. Now we have calculated the IQMs for the clean images, and also we have calculated the IQMs for the same IQMs for the stego images with the embedding rate 1%. Okay, so these are the measures for mean cost measures for the cover image and stego images. Now these are for the correlation measures. So here cover images and the stego images. Now this is the GUI snapshot this I have taken. So the true false. So this is confusion matrix. This we have used the confusion matrix to calculate the parameters performance measures. Okay, so 1% embedding, 3%, 5%, and 10% embedding. And at the end, just we have compared the results with the standard standard papers. So these are the results, right? So here, so it's a clean, now it's a DCT, spatial, and DWT. So performance of the classifier increases with respect to the embedding ratio. The 5% and 10% embedding ratio has the high accuracy. Now, so here we have got the high accuracy for the 5% embedding and the 10% embedding. So this is the performance of the SVM. It's a multi-class SVM. Yeah. And this is the comparison of my results with the results which are shown in the literature. So yeah, I'm able to achieve the 98.26% of the accuracy for the spatial DCT and DWT with an error rate of the 6.52%. So this is the conclusion for my work. So different steganographic algorithms use the artifacts in stego images. That is embedding in image changes statistical properties of the images. So out of 26 IQM pixels measures are used to discriminate between the cover and the stego images for the spatial domain. The prominent features are identified for the universal steg analysis, that is PIQMI. The feature set is generated for training and testing purpose for the multi-class discriminator. The GRUS is proposed, that is the golden ratio. The universal steg analysis proposed for the IQM calculations, which gives a significant statistical distortion in a feature sets. So the detection accuracy rises from the 2 to 4% for the multi-class discrimination. Thank you.
Hello, Govind sir.
Hi, ma'am.
Excellent presentation, sir. I believe, starting from the slide number 3 or 4, our work were completely orientation towards the analysis only. So I'm really very happy to see, to what kind of work and there's a dedication, in these numbers and the figures and the conclusion after every slide. So I'm really happy to see, and I'm witnessing such a canvas that I can see what people are actually doing.
Thanks, ma'am.
So I've got a couple of questions to you, sir.
Yeah.
If you can go to your slide number 1. So yeah, I want to ask you, do you really feel that steganography is not safe? Steganography is safe. You said in between somewhere, right? So do you think
steganography is safe for the
safe to go ahead with?
Actually, steganography it is safe for the covered communication. If you want to make a communication between two parties, okay, without knowing that communication to the another one, so that is for the covered communication, steganography is a safe one. So for the secure communication and same, so that's why the terrorist or the miscellaneous user can use that one for the other activities.
Because stego image was, one of the tool or weapon that they have used to intimate. There are many attacks has happened in the USA and Pakistan and India also. Yeah,
actually, I have skipped that one. So I am having the paper cuttings of that one. So in 2611 attack, so the terrorists has used that communication. They have used the steganography for the same one. So that I have skipped that one. Okay. Actually, that is our aim of my work. So most of the time we are having the some media or some images on social media, but we don't know, the human visual system are not able to detect what is exactly. We just, as a human visual system, we see that it's an image only, but there is something hidden in that one. So that is the aim, to detect that one. The targeted signals is what it does. So what kind of algorithm is used? So exactly the reverse process is going to apply that one, and they are trying to fetch that one. But the embed, who is going to embed that that person, and who is that as a third party, we don't know that which kind of algorithm is used for the embedding purpose. Okay, so our aim is our research work aim is that to detect such type of the communication. Okay. And just try to identify what kind of the embedding technique is used, what kind of the domain is used for that one, and what kind of the message is going to be sent by that covered communication. That is the aim of this work.
Okay. Okay. And how, like, I'm really surprised, multiple times I read your title. What's, what challenges you really find in an existing system, that you need to club everything. There are a lot of things that, you try to do it all together.
So these are the 5 challenges. The first one is that the differentiate between the cover and stego images, because human visual system doesn't know, we can't compare this, which one is stego and which one is the cover image. Okay.
Let me interrupt you. That is not challenges. I mean to say, is there any, are there any use cases that you have? Because I believe this is your PhD topic that you're So is there any, are there any live use cases that you really gave a justice to them? Because
in cybercrime. In cybercrime, so most of digital that is the digital forensic analysis. So we're going to use this tool. So most of the time for the covered communication, someone is going to use the stego images. That is a multimedia type, multimedia files. So you can say it's the image file. It's for the covered communication. Okay, and after the use of that file, someone is going to delete that file. Okay, so using the digital forensic analysis, we'll try to retrieve that file, and we'll try to analyze that file, what exactly that file contains. Okay, so that is the social aspect of this work, the digital forensic analysis.
Okay, and I'm surprised, somewhere in your slide you have written the size of your image is 512 by 512. So why are you?
Okay.
You got it, I think.
I got it. Actually, this is a slide. So I need to compare my result with the standard one. That is the main motto. Okay. So I have gone through near about 126 research works. Okay. And from that one, I have found out near about 22 research works are there who have worked on the BOSS-based data set. Okay. And the BOSS-based data set has that images, that is 512 by 512. So some are gray images are there, some are the color images are there. So that's why I have used that data set.
Okay, but don't you think so you are restricting your research work there? Because, extensively experimentation you did.
Just for the comparison purpose, just 2 or 3. Actually, first thing is that I need to propose a new approach to calculate the features. That is a golden ratio. Okay, that is one thing. So for that one, I require a standard results. Okay, so that's why I use the BOSS base. Now in next experiment or next work, what I'm going to do, just I'm going to use a general images from that one. So we can download any images from the social media, and I'm going to work on that one.
Okay. I've got a couple of more questions to you. Sir. Is there any simulator that you have used to extract those, clear results? Simulator. Is there any simulator that you have used for your experimentation?
I have used the MATLAB. Okay, I have used the MATLAB, but I have not put the results of that one. So I have compared the results also.
Okay.
I have not used that one. So in another paper, I'm going to put that one.
And in your comparison, I got that you are comparing just your results with your results. I did not find a comparison with what literature you did and their experimentation and their, all over performances and then our work.
In last table, just I have put the summary of that one. So here it is. This one. So in 22, so they have worked, it's a target one, spatial domain only. So the training and classifier is a linear one. So the payload, that is the embedding ratio. The data set, they have used only 12 data sets. So detection rate, it was 72.08%. So the error rate, it's not reported in that paper. Now in 33, it is somewhat the universal one, because spatial, they have worked on spatial and density domain. Okay, so similarly, the 70 is the density only. Actually, they have worked on the DCT and wavelet domain. Okay,
Mhm.
so it's 71. Okay, and in proposed one, just I have worked on the 3 different domains: spatial, DCT, and DWT domain.
Oh, okay.
Okay.
That's perfectly fine.
Yeah.
And you said that applications are going to be, like where you feel that they're going to be a terrorist attack or going to
Yeah,
happen.
yeah.
In my opinion, if you work with a DWT, that is wavelength transformation, with
Okay,
that
ma'am.
you can go ahead with a multimedia platform also. Like that nowadays the definition of digital information transformation is
Yeah,
too
audio
much
and video files.
extensively.
Yeah, yeah.
So that will be the better application of it.
Okay, ma'am.
The same,
Definitely.
the same you can continue, and of course the same kind of the experimentations with the result set.
Okay, ma'am. Definitely. We'll consider this one a session. Good session.
Okay, and this last question to you.
Yeah, ma'am.
Can you tell me a comparison between your GRUS, DCT, and wavelet for their time factor?
Yeah, actually, the GRUS. So it's a yeah. So already I have worked on that one, but I have not mentioned here. So basically, what we're going to do. So GRUS, yeah, here. Yeah. So
Because
yeah, it's a Fibonacci
put
series.
more comments on it, because
Yeah,
the processing time is too much here, in my opinion. I feel that
no. Okay.
the application is going to be a defense kind of the application where we have crucial time factor constraint.
Yeah. Okay. Just a couple of minutes, I will explain. Now, basically, what I'm going to do, just I'm going to use a GRUS, that is a golden ratio. So basically, golden ratio, it is going to use a Fibonacci series for that one. So first term it will be 1, then second term it is going to be the 1, third term it is going to be the 3, and next term it is going to be the addition of the previous 2 terms. Okay, so the time complexity, it is going to be the big O of n raised to 2 by 3. Okay, so because we are going to divide the data set into a 33 and 66%. Okay, if we are able to get the result in 66% or 33, if we are going to get the result in 33%, so the obviously time complexity is going to be less one. So in that case, the time complexity, it is going to be the big O of that is n raised to the 2 by 3. Okay, and if I'm going to consider the whole image, in that case, it is going to be the ns square. Now, most of the time, what we are going to do, if we want to hide the data in an image, so we need to identify a high intensity part in that image. Okay, like the edges were. Okay, so somewhat what will happen now, if you are going to calculate the whole image, so obviously there will be wasted time. Now, using this golden ratio, we're trying to identify, we're going to divide that image into the number different blocks. Okay, in first iteration or second iteration, if you are able to get that high intensity block, so obviously we'll get that good result in that block only. Okay, so in this way, we are going to decrease the time complexity.
Okay, and investing the time to find out the large intensity pixel, that also needs to be taken into consideration.
Yeah.
Okay, anyways, it
actually
was
technology is a part
discussion.
of the pattern recognition.
Exactly.
Yeah, exactly.
Okay, thank you so much, sir.
Okay, thanks, ma'am.
I really appreciate the topic.
Yeah, thanks.
Thank you so much for the presentation. And now we'll move forward to our next presenter. And I would like to invite Ishita Goyal to present her paper on the title OMA DSS Ontology-Based Multi-Agent Decision Support System in Healthcare Domain to Prevent Cardiovascular Diseases. Dear presenter, you can start your presentation now.
I hope my screen is visible.
Yes, it's visible.
Good evening, everyone. My name is Ishita Goyal. I'm really sorry. Just give me a minute. I'll settle down. My name is Ishita Goyal, and I am a health policy researcher. Based on my work, I am working on personalized medicine. Basically, I'm working on the policy system that should be incorporated in our Indian healthcare system.
based on my work, I'm sorry, I am working on policy of adoption and policy making of personalized medicine in India. And based on my work, this is like a small implementation that could be brought into this healthcare system. I'm not a computer science or IT. The idea of the paper is mine, but I have taken help with the author, that is the co-author of the paper. So here I'll present the idea of the paper. So extraction of patients' relevant information from a cluster of web documents and traditional hospital system where papers are used, it's very difficult for users to get meaningful results from those things, and it becomes a cumbersome task for everybody. And the traditional methods fail to tell us about the early signs, that is the precautionary measures that one should take for a human health. The solution to this problem lies in employing agent-based integration approach with the help of ontologies. The agent-based integration here I'm talking about, for example, notifying something that is getting noted somewhere, an intelligent mechanism that is being employed to find out the best possible solution that from the notifications that we are getting, and the best knowledge discovery that we can get from the data that is available to us. So several methodology and application needs to be integrated and coordinated with multiple agents in order to provide suitable information support. Coordination of data by multiple agents lead to a decision support system. So the model that I'm proposing here is that ontological based agents data integration proposed system is which external data related to human health, whether it is unstructured or structured, is coordinated and semantically integrated by multiple agents. After integration of data, new knowledge is inferred on the basis of set of rules, thus making it a multi-agent decision support system. The proposed model is able to predict the health status on the basis of the activities performed by the humans, and the approach presented in this paper is detailed in the context of human day-to-day activities, which helps in enhancing the cardiovascular soundness of humans. This is the basic layout that is proposed in the paper. Here, if I explain this layout, here the user enters the query related to the healthcare. The traditional system has a limitation that it gives us both relevant and irrelevant records. So we have designed an ontology-based multi-agent system using a Protege editor, and basically it's a backend database, and the agent system activate by connecting with ontologies, and a Jade platform for software designing is used, and the users based on the agents, that is the notifying agent, the intelligent agent, and the knowledge discovery agent, a useful and relevant results are given to the user. And the healthcare the activities that are being recorded can, since we are talking about cardiovascular diseases here, that the physical activities that one is doing, how much sitting a person is doing, what kind of job profile a person has, how much physical involvement they have in their lifestyle, and all the other lifestyle related activities that are incorporated, and all these are kept in track, and based on that we'll get that how a health of an individual progress over the period of time. And everything, the results that we are getting here are based on the ontological database that is being created at the back end. This is the detail that I have already explained. Thank you.
Ishita, right?
Yes, ma'am.
Ishita. I believe that then explaining it was just, you were just reading the slides, if I am not wrong. Okay, anyways. Ishita,
Actually, I am a health policy researcher, and this is not exactly my field of work, but I'm
Okay.
trying to get into it because I am done with the theory part and the policy research part. But the next step is to get into the implementation, and IT is very important for personalized medicine. So I am getting into it, but I don't have a very, very strong command over it
No, no,
right
no
now.
worries, no worries. See, it is, these platforms are there for the discussion more than questions, I believe. Yeah. So you tell me, Ishita, frankly now, okay, what is your topic is all about? Then apart from what you have presented, because you
Okay.
are from the medical background, right? And they are engineers, right? So we are very much eager to know, what kind of work you did and what is your contribution in it.
Ma'am, my work is I'm working on the structural barriers and policy challenges of personalized medicine in India. So the work is that I'm looking at the clinical utility of personalized medicine, whether that system should be adopted in our healthcare system or not. The model of personalized medicine should be adopted in our system or not. And since personalized medicine, data is one of the very, very important things for personalized medicine. We need to create data, we need to store data, we need to have privacy and security measures for data. So data is the prime for personalized medicine, because the focus of personalized medicine is the right treatment should be given to a right person at the right time. So there are, like for example, if I tell you, if we are giving medicine to a person, we don't get response of 100% every time. Some medicine can suit you, but it may not suit me. So the basic behind this thing is, sometimes the environmental factors also play a role, but most importantly the genetic factors that come into role. So there should be a database that should be created for these genetic factors, and with the environmental factors, like for example, if I have a very sedentary lifestyle, and my already my family has a history of diabetes, so there are greater number of chances that I'll get diabetes, maybe later stage of my life. I have a genetic profile there, as well as the environmental conditions for getting the disease. So
Right.
all these things should be present in our information systems. The database should be there for so that if I'm not aware, I'm not from a medical background, I don't have anybody, but if I put something on the internet, because internet has so much power these days, so if I put something on the internet, sometimes it gives us such big names that if I put a headache, I might get results like you may have brain tumor or something. So
Okay, okay.
the
I got
idea
it.
is
I
to
got
get the
the
most
essence
relevant
of what
information.
you are saying. Okay. So how will you relate what you said now is with your topic?
Ma'am, here the topic idea is that same thing that I was talking, that there should be databases. If I'm putting, like for example, I have there is a software that tells me that asks me that how much do you walk, how much do you sleep, how many hours do you sleep, how many hours of sitting work you do, what kind of physical activities you have. I put in these set of questions in that software, and that software might give me the idea that
Okay.
what kind of cardiovascular disease, or what is the state of your heart at the right time, at this time.
Okay. 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 Okay, Ishita.
I
Thank you so
hope.
much.
Thank you, ma'am.
Okay, thank you for the presentation.
Thank
And
you.
now moving forward to our next presenter, Hugo Arias Flores, and the paper title is Playful Thinking as a Strategy to Assess Mathematical Skills in Primary School. But I think he is not present in the meeting. So we'll move forward to our next presenter. Yeah, and I would like to invite Geeta Babu Singh to present her paper on the title Single Image Dehazing Using Haze Veil Analysis and Contrast Stretching. Dear presenter, you may please start your presentation.
Okay, thank you, ma'am. My voice is clear, ma'am?
Yes, it is.
Okay, thank you. Good evening, ma'am. My screen is visible or not, ma'am?
Yes.
My screen is visible? Okay. So, good evening to all. Myself, Geeta Babu Singh. So, I am presenting a paper on single image dehazing using haze veil analysis and contrast stretching. The content of present work is abstract, introduction, literature survey, proposed work, methodology and implementation, result and discussion, conclusion and other reference. So let us start with our abstract. So that is, image is usually degraded due to the scattering of light caused by small particles, for example, fog, haze, smoke, etc., present during a bad weather condition. The haze makes the image processing and computer vision system failure because haze diminishes the visibility of scene. Haze removal is one of the challenging issues in image processing. The efficient method is proposed for single image dehazing approach using haze veil analysis, adaptive contrast stretching, and contrast limited histogram equalization, that is CLAHE, are applied to enhance the visibility level of defogged images. Introduction. Usually, photographs of outdoor scenes are degraded under bad weather conditions and bad environments, resulting in haze picture. Such images suffer with low contrast, blurriness, and poor visibility. Image dehazing is a procedure of removing the haze from haze image to get an enhanced haze-free sharpened image. This paper present dehazing approach using image haze veil analysis presented by Fan G et al. So my present work is based on this paper. So as you can see in this picture or in this figure 1, we are having the images which are having the poor visibility, poor contrast, and fog. So I have referred many papers. Some of them are here. That is literature survey, in which many of the single dehazing method use dark channel prior, that is DCP approach, introduced by He et al. Then the TAN method is based on single image dehazing. This methodology is based on optical model, which is made up of two terms, direct attenuation and air light respectively. He continued by defining it as a color vector suggested method is the presumption presumption that is so can you give me 1 minute, ma'am? So method use wavelength transform to remove haze from a single image. It entirely focus on
Ma'am, Geeta ma'am.
so sorry, ma'am, my eyes.
No, there is
So-
a request to you, ma'am.
Yes,
There's a request to you. I am very much excited on what did you do, than just going
Okay,
slide
ma'am.
by slide.
I'm
No, just let's have some interaction.
I'm
That will
skipping
be
with
enough.
this
Yeah.
guy. Okay, ma'am. So my proposed work is, the proposed method is degrade haze as a valley layer. Illumination images generated using Retinex algorithm. So next, and the depth information of original image is used to remove valley layer. Adaptive contrast stretching and CLAHE techniques are employed to enhance the image. So my proposed work, so my block diagram is the original image, then whale calculation, that is nothing but Hayes whale calculation, then YCB CR conversion, then this goes to logarithmic transformation, where again we are converting it into RGB formation, and here we are subtracted the original image from RGB. So then it applied to reflectance image, where we apply our proposed method to this image. That is, first we applied the adaptive contrast stretching method, and then we applied it to Clahe method. This adaptive contrast method is based on the Fan et al. Paper. Then lastly, we get the Hayes image. So the as I told in a block diagram, first we read the RGB image, then we calculate that is Hayes whale calculation. According to Ratinex theory, the input image S is described as product of reflectance image R and illumination image L at each point x comma y, as the equation S of xy is equal to R of xy to L of xy, where star is our convolution operation. The illumination component is estimated using the following formula. Then where we compare, where we compensate for color, the uniform Hayes value, the degraded image is multiplied by means of illumination image to obtain depth like the following formula, by using following formula. So where for obtaining final Hayes value image is converted from your RGB to YCB and CR. Color space and illumination component from this extracted. So next one is our computing a reflectance. In reflectance image, the image is converted into logarithmic domain. Accordingly, this equation, that is log S is equal to log R plus log L. The reflectance image is then extracted using the formula R dash is equal to exponent log S minus of log L dash, where R dash is haze free and low contrast image. So next, when we are getting the reflectance image, there we are applying our proposed method. That is, one is using adaptive contrast enhancement, in which we are getting each where at each pixel an adaptive window is considered, and a covariance of this area is calculated. Next window is the window size is expanded around the examination point. The next is the final, the optimal window is then used to enhance the image contrast locally. Second, we apply our an adaptive extension of histogram equalization, followed by thresholding is a technique which helps the dynamic preservation of the local contrast feature of the image. It operates on small region in the image called tiles. The contrast enhancement is limited by clipping the histogram through user-defined values known as clip limit, which describes the amount of noise to be smoothened for contrast enhancement. The technique preserves sharpness, details, and increase local contrast of the pixel. So as you can see in this figure, so here we have.
Sorry to interrupt, ma'am, but
Yes.
Can you please conclude your presentation, as we are running out of time?
What, ma'am? So
please conclude your presentation. because
ma'am.
we are running out of time.
Okay, ma'am. So by applying, as I proposed in my paper, I am applying two methods. One is your two methods to a single image. The first one is Hayes Valley analysis with adaptive contrast stretching technique, and the second one is Hayes Vale analysis with Clahe. As you can see in this figure, we have the original picture or image. So next, we apply this to adaptive contrast stretching technique. So this column 2 shows the output of the first image, and when we apply with Clahe technique, we are getting this much of clear picture of the input. So my Clahe is better than the adaptive contrast stretching. So next is so here contrast to noise ratio, that is CNR. A measure to use determine image quality, the output image obtained after applying histogram technique. So the RGB image is converted to grayscale, and CNR of image is estimated by Gaussian curve. So by applying this method, so here as you can see in this table, so here the original image, then we are applying the adaptive contrast stretching to the image. Then in third column, we are applying the Clahe, where we are getting the 90.3391 output result. So it shows that this Clahe is give a better result by this adaptive construct stretching technique. So my conclusion is image dehazing is one of the challenging issue in digital image processing application. The paper presents an approach to get dehazed image using Hayes Vale analysis and histogram technique for image enhancement. Hayes Vale layer is eliminated from original image and enhancement using contrast stretching and Clahe technique. The results are better than original method because Clahe, which enhance image adaptive based on clip limit and stopover amplification. The proposed methodology is compared with with existing methods, demonstrate better result appearance, colorfulness, and contrast enhancement, resulting better quality dehaze image. The method is applicable for single image containing uniformly distributed haze. So these are the reference. Okay. Okay, thank you, ma'am.
Yeah, ma'am, it was a good presentation. I have got a couple of questions for you. Like,
Yes.
I've seen that, some parameter, you're considering the variety of images basically having the haze in it, so unclarity in it, or, yeah.
So I use, so I refer
No, I have not, wait. I did not complete my question yet, ma'am. So, yes. Having haze and, processing the pictures to go to the accuracy level, the processing that your topic is all about. So, my question to you is, are you trying any specific area for, collecting the image, or it is just a random search where you are going to get a data set from?
No, ma'am, I am collecting the 20 images, fog images, where fog images from Google only, or by camera only we can capture the pictures. That is considered as a original image, or you can say input RGB image. So,
but ma'am, no, let me.
We are not getting 100%, ma'am.
No,
just
90%. I would like to interrupt you here. No,
yes,
I would like to interrupt you here. This kind of the image are not going to give you the accurate result because it has got a lot of noise present into it.
Yes.
Yeah. So I will tell you the sequence, how you can go ahead to improve the accuracy on, enhancement of Clahe algorithm. I'm going to come to your algorithm in some time. So
okay,
in my opinion, you give a target of specific region, that is, for example, Delhi, where you see that in a extreme weathers, you get a lot of fog or haze in the images. So you collect those realistic images Number one, you pre-process the images.
Yeah.
Pre-processing the image is extremely important, for any kind of the computation, and hence it is a lot of time consuming. So you get that, and then you process for, and only 20 images are not going to be helpful, ma'am, where the world is
And
moving.
not for 20, ma'am. So I have collected 100 and many of them. So out of them, some are a real photography picture, which is taken by the camera, Canon camera. So next again from 10 or something more pictures from mobile camera. So we are studied. So we means I myself studied and apply that Clahe and adaptive contrast. And lastly, I get the result of 3
So
are the best.
yeah, that's what I'm coming to your Clahe algorithm, like Clahe and ACE that you're saying that you have done a comparison, and you have tried to put the result. So in proposed, I'm surprised, to see how you can put the accuracy for it. It's a proposed algorithm, right? It's not an implemented one.
I am not getting an accurate result, but a slight improved, I can say, because originally is giving a 75 a result,
So,
and my Clahe giving a 90.3391%.
Achha,
So
you have already implemented the prototype of it? Oh,
yeah,
okay. Then you should have said here implemented, than proposed. You're saying it is been proposed. Okay, anyways, no worries, ma'am. That is perfectly fine. That's it from my side, ma'am.
Okay, thank you, ma'am.
Okay.
Thank you.
Okay, thank you so much for the presentation.
Thank you.
And now we have completed all the presentations, and I sincerely thank all the authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. And I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 6th version of the conference, and we will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months, so kindly cooperate with the team of SMARTCOM. And I would also like to thank our session chair, Professor Priya Pite, for chairing the session. And here is a small token of appreciation on behalf of the team of SMARTCOM and Global Knowledge Research Foundation. So thank you so much for your valuable presence, ma'am. Ma'am, you're not audible.
My side, I also thank you, ma'am.
It was indeed a pleasure to meet all the participants here all over the.
No, ma'am, you
country.
are giving me chance to present my paper. Thank you, ma'am.
Thank you so much.
Okay, so now as we have come to an end of the session, I request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.
Anisha, there's a request.
Yes.
Can you just go to the slide that we have, the
Okay.
earlier last slide? I forgot to take a pic.
Ma'am, I'll send you the photo of that.
Okay. Okay. Thank you so much.
Okay, thanks a lot.